Okay. So thus far, we've worked with everything with all positive values. And that gives us a lot of trig functions, but our goal next is to be able to extend that idea into the negative numbers and consequently all real numbers, which is just pretty powerful. But in order to do that, we have to place these angles on a coordinate grid, kind of like we talked about with the positive and negative angles last week. So I'm going to give you a point that is located on the terminal side of an angle. So for example, this is some negative angle theta. Okay? Some negative angle. It doesn't matter what it is. We don't need to know that. But this point is located on it. And the location of this point is negative 15, 10. Oh, excuse me for 1 second. I'm sorry. I have to pick this up real quick. Hello. Yes, ma'am. I'm actually in the middle of teaching class right now. Is it possible for? No, it's fine. I just wanted. Okay, no worries. I'm free probably about 12:15. Is it urgent? Is it something I need to know now or? Perfect. Yes, just give me a little bit of time. What time is a good time for you to call me back? And I'm free anytime between 12 and 12:30 and anytime after 1:30. Okay, perfect. Thank you so much. All right. Thanks. Bye-bye. All right. Sorry. Okay. So anyway, this point is located on the terminal side, and I'm going to have to pick back up in my mind where I was. So we are trying to find the value of tangent of this angle only knowing this point. And this is actually really, really easy to do, and it's actually kind of a review from what we did last week. So what I'm going to do here is I'm going to take, let me get a different color. I'm going to take from this point, I'm going to drop a perpendicular down to the x-axis. Here's the deal. You always want the perpendicular to go to the x-axis, not the y. Okay. Recall from Delta Math on Friday, if you made it through the reference angle part, the reference angle is defined to be the angle between the terminal side and the x-axis. And so really, that's what we're constructing here, a reference triangle with the reference angle theta. And so this is theta right here. And I have this lovely triangle, and I can make some labels for this triangle. The horizontal component is negative 15, and because we are extending at this point into the negative values for the trig functions, we will keep that negative there. Because the value of the trig functions, even though numerically are the same in all the quadrants, they are going to be different signs as we move through. So it's important that we maintain that. And so the vertical component, the y component of that point, is going to be 10. And at this point, it's going to be very simple for us to find tangent of theta because based off of theta here, this is h, this is a, and this is o. And the tangent is defined to be the opposite over the adjacent side. Okay. Well, I have those numbers already, so this is reduced to a pretty simple process. So it's 10 over negative 15, which reduces to negative 2 over 3. And that is the value of tangent theta. Okay. All right. So the instructions ask you to do two other things on each one of these problems. So this is the numeric value of the ratio tangent of theta. And then I'd like you to tell me what quadrant the terminal side is in. This is quadrant 2. And then I'd like you to tell me the sign. I can clearly look here and see it, but I want us to draw our attention to it. The sign is negative. And so this is the format that your answers will be in. I will need those three things specifically stated on this. This is setting us up to start realizing that there are patterns for the location of the terminal side of the angle and the respective trig functions for that angle. So for example, here, tangent is negative in quadrant 2. And it's always going to be like that because we're always going to have a negative horizontal component and a positive vertical component. That's what makes up tangent. Okay, so let's do another one. Let's do the secant of theta. And notice now I'm in a completely different quadrant, and so my triangle is going to be drawn sort of different. but I'm just going to go directly to that x-axis, okay? Let me show you what not to do. Do not do this. This is not your triangle. This is not it, okay? It's the one with the x-axis. And so your reference angle, you know, theta or theta prime or whatever is going to be right there. And then we'll label the lengths of said reference triangle. In this case, the horizontal component is square root of 11, and the vertical component is -5. Now, thinking back to how we define the ratio secant of theta, that's going to be, it's the reciprocal of cosine, which is a over h. This is going to be h over a. And notice I'm missing the value for the hypotenuse, and so I'll need to find that. So using the Pythagorean theorem, that'll be the square root of 11 squared plus -5 squared equals c squared. And so, you know, here's a fun fact, because any negative number squared is a positive number, you will never, ever, 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 ever have a negative value for a hypotenuse. And if you do, you did something wrong, okay? The legs of the triangle can be positive or negative. The hypotenuse is always positive. So let's solve that. That'll be, what does it end up being, 6? Mm-hmm. Is it 6? Okay, thanks. Save me some time. Let me label that here on my triangle. And let me just remind myself of what all these values are. This is the hypotenuse, because that's my right angle right there. This is the adjacent, and this is the opposite. And so now let's construct the secant of theta, which is h over a. Now clearly we can't leave that radical in the denominator, so you'll rationalize that in your calculator. When I say rationalize, I just mean get rid of the radicals in the denominator. And so your final answer here should be 6 root 11 divided by 11. And so this is the numeric ratio. Okay, this is the secant of theta. And then remember, there are 2 other components that I want you to do, and that's going to be list the quadrant. The terminal side is in quadrant 4. And the ratio is positive. So secant is positive in quadrant 4. And again, that's always going to happen because the legs of this triangle are always going to be constructed the same. You're going to have A is going to be positive in this case, and the H is always positive, so it's always going to be positive. Questions about this one? Like I said, we kind of touched on this on that very first day. So all I want you to do on this, and I'm going to give you another, I'll give you some time to work on this, 20, 25 minutes maybe, I don't know, we'll see. But we're going to do 2 through 8, so the rest on the front, okay? Not the back, just the rest on the front. So you don't have to find all the ratios, just the one I asked for. List the numeric value of the ratio, the quadrant, and the sign of the ratio. And that's it for that one. And then I'm going to be handing out a bunch of things to you that we'll get together on so I get you. This is the 18th, and this is second block. You're very welcome. If you get done with those problems earlier and you want to bounce back to what we were doing before, you can do that. Or I've posted an optional quiz practice. It's completely optional. The key is posted. It's in Classroom. If you want to spend any extra time today kind of looking over those things, it's a really good representative question set of what you'll see tomorrow. But that's, again, it's optional. It's not required.